Hello everyone. In today's video, we will be seeing regarding how multi-edge shard, okay, using Qdrant Edge, partitioning data across local shards, okay. Here the thing is, if you had not watched previous videos of how we use Qdrant Edge, okay, on local device using no networks, no servers, and no API keys, then make sure to watch those videos also, as you will be gaining much more information regarding how Qdrant Edge is useful when using databases across a larger scale. Okay, so starting in this video, every Qdrant Edge tutorial you have watched makes the same assumptions: one dataset, one folder, one shard. You create a client, you point it at a path, you are done. But what happens when that one dataset is actually three different companies, confidential documents, or 5 years of sensor logs where you only ever care about last week, or two completely different vector shapes, small text embeddings sitting next to giant multimodal clip vectors? Today, we are going to break that single shard assumptions on purpose. We are going to physically split one dataset across multiple local Qdrant databases, build a federated query layer that fans out and merges results across them, and one more importantly, figure out exactly when this is a genius move and when it's just complexity you didn't need. Okay, so like showing right after, I will show you regarding the Qdrant documentation page, where we will be heading towards the edge part. Okay, so yeah, as you can see here that this is the documentation page of Qdrant, where Qdrant Edge is listed. And here I went looking for content on this before recording, and it's genuinely thin. Qdrant Cloud has distributed sharding back then. Qdrant Cloud has distributed its solved problem there. But on the edge, your laptop, a mobile device, or a local desktop, okay, sharding isn't automatic. You control the file, and which means you decide whether to use one database or 10. Almost nobody talks about the local case. Okay, so I will show you another page regarding that. Just one second. I think, yeah. So here you can see the proper Qdrant Edge page on Qdrant website, and here you will be briefly showing the local quick start page and the note about Qdrant Edge running embedded inside your application. Okay, so basically here you can see that all the documentations regarding Qdrant Edge, how it's working, and all the things are on the Qdrant Edge page, and also on the documentation part, where you will be seeing the quick start page, where how you will be integrating the Qdrant Edge, okay, to your local directory or your local computer. Okay, so basically this is how it works. So starting with the import part, like you will be sharding the directory towards the code, and then configuring the edge shard, which will be like something vector name and the vector dimensions you are using. In previous video we go through regarding how edge shard you can use and properly go through it. Okay, so then the initialization of the shard, then how it's working with the points. Okay, so all the things are mentioned on the documentation and quick start page. And also here you can see the on device embeddings. Okay, like how you will be taking the model and doing the embeddings of the document or the database which you have. Okay, so that all the things can be retrieved very fast, and Qdrant Edge is has the least retrieving time. Okay, Qdrant basically started with the database part, and then Qdrant launched Qdrant Edge. Okay, a best way to retrieve the datasets and the vector embeddings of the data. Okay, so that's how it works, and I will show you. Yeah, so here you can also see the quick start part. Okay, like the local quick start of how Qdrant works, like using Qdrant client. Okay, and the edge part, here you can see that how you can quick start with the Qdrant Edge. Okay, so go through once all the pages. I will list out the links in the description so you can go through it. And yeah, so let's start with the code, like how it will be running. Okay, so first running with like installing the Qdrant client, and once it's done, let we will be moving forward. Okay, so basically yeah, so all the things are run. And why does local sharding actually help? Okay, like so when you will be seeing that before we write a line of routing code, let's be honest about the trade-off, because sharding is not free. Okay, so when to shard locally, here's the part that yeah, hard isolation and compliance. So basically, if a tenant asks you to delete their data in a single shared database, you run a delete query and hope the vacuuming actually reclaims disk space. With physical sharding, you just do on their folder. The data is gone instantly. That's a very different compliance story. The second comes the selective loading. Okay, so basically selective loading for RAM in constrained devices. Okay, so Qdrant memory maps files to RAM. If you are storing 5 years of logs, but 99% of queries only touch the last 7 days, loading everything into one giant index is wasteful. Okay, shared shard by time window, say one shard per month, and only instantiate the clients for the months you actually need. Third is avoiding giant memmap files. Okay, so on constraint for or edge operating systems, one huge file can be less stable to manage than several smaller independent ones. Okay, I as you can see here in the avoiding giant memmap files. Okay, and fourth comes the different vector configurations per modality. Okay, so small dense text embeddings and huge multi-model clip vectors often need very different HNSW parameters. Separate physical databases, keep that clean instead of forcing one index to compromise. Okay, so basically yeah, that's how all the things are needed. And that's how when to shard locally is seen in this video, and we will be going through it. Okay, yeah, so we will be starting with building the multi-shard manager. And yeah, so starting with that, once we will be running this. Okay, I will show you regarding how the code is and what the code is. Okay, yeah, one sec. So let's build the router. First install Qdrant client, and fast embed gives us fast lightweight local embeddings. Okay, then comes the part here where the federated Qdrant Edge class takes a base directory, a collection name. Okay, see here you can see the collection name and a vector size. Internally it just holds a dictionary, shard name to Qdrant client, and on startup it auto discovers any shard folders that already exist on disk and reloads them. The real trick is init shard. Okay, see the federated Qdrant edge is here, and then comes the init part where for every shard name we create a current client. Okay, so path equals shard path. Okay, notice this is a local embed client, not a server connection, pointed at its own subfolder if the collection doesn't exist yet inside that shard we created. Each shard is a completely independent Qdrant database sitting in its own folder. Okay, so that's how we will be initiating with the init shard. See the self start and the shard name, then initializes or retrieves a local Qdrant client for a specific shard. Okay, then comes the defining part of the client, like yeah, see what I hit till. And yeah, so then comes the insert function where routes data to the correct local shard based on the key tenant ID. Okay, so I talked regarding how it works. Okay, just some time above. And then comes the federated search function where the query vector is in the list, and target shards are optional, but also list as a string, and query vector is a float, and the limit for this is 5. Okay, and 5. Now fans out the query to target shards, then merges and re-ranks results globally. Okay, So that's how it works. All the results are stored in a list, and then yeah, starting with the query part. So this will fetch limit from each shard using the newer query points API. Then merge and re-ranks, so sort all collected results globally by score. Okay, and then truncate also, like the return the global top k parts. Okay, so it matches the score, and according to which the highest score will be shown at the top. Okay, so yeah, let's run this and we will see like yeah, the multi shard manager, like how it works. So basically it run and no error came here. And then the use case of multi-tenant edge shard agent. Okay, so basically yeah, in this case let's simulate an edge application that processes confidential data for three different companies. Okay, now here you can see that yeah, we will be printing that, and then the vector size is 384 dimensions. As we can see, the bg is small. Here the model is, see, the model name is bg small en v 1.5. Okay, and then the initializing our federated manager, where the base directory is the base shard directory which we initialized in the above code. Collection names are docs, and vector sizes here we can see. And then we will run this. So what will happen, see, I think, one second. Yeah, so the fast embed model is loaded, and then when dummy data for three tenants. Okay, so here you can see that the Stark Industries, Wayne Enterprises, and Cyberdyne Systems. Okay, so that's a test data in which the text is there, or the type of that, like blueprint or manual or log or code or report, all the things are in a data. Okay, and then once I will run this, hope you can see that yeah, inserted 2 points into shard for Stark Industries, 2 for Wayne Enterprises, and 2 for Cyberdyne Systems. So all the things are inserted in the shard itself. And yeah, so let's look at the physical file system. Okay, so once I will run this, and here you can see that yeah, physical directories created on the disk. Stark Industries like collection, meta.json and log, and then further same for the Cyberdyne Systems, and same for the Wayne Industries. Okay, sorry, Wayne Enterprises. And here's the folder structure, and then comes the step 3, the federated querying. Okay, now we can choose to query a single shard or query multiple shards and merge the results. Okay, so starting with yeah, the query text is advanced, see here, advanced armor and robust suspension, vehicle suspension. Okay, the vector is yeah, so we will be integrating the embedding model which embeds the text and stores in a list. Okay, see, so the print will be query and the query text. How it will be? Scenario 1 will be the selective loading and strict isolation, in which, see, here single shard query. Okay, so we will be running for only Wayne Enterprises. And yeah, so here you can see that the target shard is Wayne Enterprises, the same name which we initialized further, and the query vector. Okay, and then comes the, sorry, yeah, so we will be, yeah, then comes the result, the payload, the source shard, and the text which will be generating. Second comes the global federated search, where all the shards are merged and then the result is initialized. Okay, so once we will be running this, and yeah, here you can see that the query for advanced armor and robust vehicle suspension. See, so the scenario 1 is single shard query for Wayne Enterprises. In this, see here, what I said is, here's the score will be there. Okay, tumbler suspension stress test logs and sonar mapping tool configuration. Okay, so basically it retrieves the data from shard, it embedding model runs there, creates the embeddings, then those vectors are stored in the database, and according to the matching of the keywords, okay, these scores are given. Like here we can see that are 0.7, 0.51, and this is for single shard. Okay, when coming to global federated query, where all shards are combined. Okay, so fanning out this, and Stark Industries, Wayne Enterprises, and Cyberdyne Systems. Okay, so 0.73 for the Stark Mark 5 armor deployment sequence. Okay, then comes the Wayne Enterprises tumbler suspension, and then comes the Cyberdyne Systems, where T800 alloy composition analysis. Okay, sorry. So all the things are working properly, how single shard is working and how all the shards combined and a multi-shard system is working. Okay, so that's how it works. And then comes the true physical isolation. Okay, so basically in a single database, deleting data means running a query, okay, like delete where tenant id is cyberdyne, and hoping the db vacuums it from disk properly. While local sharding, if a tenant leaves, you just destroy the folder, it is instantly and permanently gone from the disk. The thing which we created is, yeah, here you can see that three folders are created. Okay, so when we will be using global shard, those three folders will be retrieved, and if I have to delete anyone, so I will just delete this folder and this will be gone. New data will be with cyberdyne and vane. Okay, so that's how it works. Yeah, here we can see that, yeah, fed quadrant or we are dropping the shard cyberdyne systems, we're verifying that we will be also verifying the directories. Okay, so once I will be running this, and here you can see that, yeah, hard deleted shard this from the disk. So the new disk will be Stark Industries and the Vane Enterprises. Okay, and now we will be running the global shard, and here you can see that, yeah, fanning out query to shards is Stark Industries and Vane. Okay, so cyberdyne is totally deleted and all the things are working. So here you can see that, yeah, Stark Industries part is coming and the Vane Industries Enterprises part is coming, but cyberdyne systems is not coming. Okay, so uh, uh, yeah, so that's the whole point of this video, showing that, yeah, how multi-shard is working properly, like partitioning data across local shards. Okay, so in this video what we have is, we created three different shards. Okay, one is the Stark Industries, second is the Vane Enterprises, and third is the cyberdyne systems. Okay, and according to that, we finally got the structure of the folders, all the three folders, and then we run a single shard for a separate company and a global shard in which all the three are combined. Okay, so here you can see single shard is for Vane Enterprises and global shard is for all the three. Okay, and then if I want to delete any one of the folder, okay, so what I will do is, I will just drop the shard of which I want to delete, and then here you can see that, yeah, the directories are verified, the shard is deleted, and also the output is working properly. Okay, so that's how multi-shard and single shard things are working according to Qdrant Edge. And saying again, these all are working totally offline. No API keys are there, no network is there, no server is there, totally running on your local device. Okay, so that's how it works. You can also check out all the, see, so here the Qdrant client GitHub is there, which is also open, and I think Qdrant Edge is also there. Okay, in the repositories part, or either you can go and just search for it, like what here, Qdrant Edge GitHub repo. Okay, so once this search will be complete, here you will be getting the one sec, I think not this one, yeah, yeah, so here you can see that it's also working properly in different domains also. Okay, and properly on your own device, so no, do not need to worry about that. And that's how the semantic search engine works. uh, One last thing, okay, so installation of the sentence transformers, then importing the models, yeah, mini lm l6v2, and then all the, see, here's the database also, and then creating the collection, then the vector parameters, then the models, and after uploading to the collection, ask the engine and it will give you the outputs. Okay, so that's how it works. All the things are, you can also check out all the things on Qdrant website, the documentation part, and also here you can see the edge where all the things are there, the data synchronization and so on. So that's it for today's video. Hope you learned a new thing regarding how Qdrant Edge is working in single shard and multi shard technologies. And yeah, if you gain best knowledge from this video, so just like, comment, share and subscribe to Hidevs, and we will meet soon in another video learning new things about Qdrant Edge. Okay, So thank you, keep learning.